Chapter 9, Lesson 6, we are analyzing data distributions. Okay, think about the word distribution. That's what we're going to talk about, how it is distributed. Okay, four major terms that you're going to talk about with every single problem today is a gap, a peak, an outlier, and a cluster. And you almost don't even need to give a definition. A gap, it's a gap. How would you, what would that be, right? Where there are no data values. It's a spot where there is nothing. A peak is where it's very high or they are the biggest one. So grouped together, no, most frequently occurring value, there we go. It is the most frequent. An outlier, okay? Now, an outlier, this gives an actual definition, and today I'm going to show you how we actually calculate an outlier. 1.5 times the interquartile range from the two quartiles. And we'll talk more about that in a minute. And obviously a cluster where they are grouped together. All right, a cluster. All right, so finding an outlier. This is what I was talking about. Now, prior to this, when we talked about outliers, if there was one kind of just hanging off by itself, we just said, yep, we think that one's an outlier. Believe it or not, there's actually a mathematical way of determining outliers, and it is right here. Interquartile range is the difference between the third quartile and the first quartile. Remember, we found that. And then we take that value times 1.5, and then we go that far above or below the quartiles. Let me show you what I mean. Okay, so finding an outlier. If this is my example, and this is a 5-number summary, so we got the minimum, the quartile 1, median, the quartile 3, and the maximum values. Okay, so in order to determine if something is a quartile, we have to find the interquartile range, which is quartile 3 minus quartile 1. In this case, that would be 31 minus 17. Okay, 31 minus 17, I believe is 14, but let me just double check. I don't want to be wrong. Ooh, good, I'm right. So that is 14. That is my interquartile range. I then take that amount times 1.5. So I take 14 times 1.5, which is going to be 21, I think. Yep, 21. Now I take that value and I take the first quartile and I subtract that value, and I take the third quartile and I add that value. I go below the first quartile, so that would be 17 minus 21. Well, obviously that's a -3. Probably not going to have an outlier below this, but quartile 3 is 31 plus 21, which would be 52. So this gives you a range of numbers. If you have any numbers below that or above that, they would be considered outliers. That is how you find and determine an actual outlier. Okay, and we will come back to that again. But let's move on. Describing a distribution by its shape. Okay, there are two things, symmetric or non-symmetric. You know what this means. Symmetric is the same on both sides. It looks like this. It wouldn't have to look like this. I mean, it's rare in occasion, but sometimes it might look like this. Right? And so that's still symmetric. It's just low in the middle and gets higher as you go away. Those are terrible x's. Sorry about that. X, X, X. There we go. X. So, but this symmetric, so it is symmetric. So that's what you look at. And this one is not symmetric. It doesn't look the same on the left or the right. Okay, so first of all, symmetric or non-symmetric. That's when you're describing your distributions. You also want to talk about clusters, gaps, peaks, and outliers. Last but not least, an outlier. Okay, so let's look at this. Let's practice over here on slide number 4. We've got a bar graph over here. So the weight of adult cats. So there is one adult cat that's 7 pounds, and 2 that's 8, and 2 that's 9, and 3 that's 10, and 2 that's 11, 1 that's 12, 1 that's 14, and 1 that's 15. Okay, so distribution, is it symmetric or not? Okay, the answer to that is not symmetric or non-symmetric, because it's not the same on the right as it is on the left. The second thing we're going to talk about is clusters. Okay, anytime clusters and gaps kind of go together, because if there's a cluster, there's probably a gap, because if there's a group bunched together, then there's probably a space between those groups. So I'm going to say we've got a cluster from 7 to 12 pounds and 14 and 15. Or 14 to 15 pounds. There is definitely a gap then. Our gap right here is at 13 pounds. A peak, our highest point, okay, there's a peak at 10 pounds. And an outlier. Now, there really isn't an outlier. I mean, I know we have these two up here, but they're together, and they're really only one spot away, so no outliers. All right, so when we are discussing distribution, those are the 5 things we're going to talk about. Now, there might not be a gap, there might not be a peak, there might not be clusters, and you just say none if that's the case. All right, let's flip that paper over. Let's try this again. Now, this is a line plot, okay? I know that you've seen them, but sometimes you forget what they're called. What this just means is that there's 2 58s, there's 3 60s, 61s, and so on and so forth. That's a line plot. All right, so distribution, is it symmetric or non-symmetric? It's not the same on both sides, so it is non-symmetric. There are clusters. I would say there's one main cluster right here from 60 to 63 inches. There's a cluster. There's a gap at 59 inches and another big gap from 64 to 70 inches. There's a peak at 61 inches and an outlier. Now let's determine if this is an outlier. 71, I would say there's a pretty good chance, but let's practice determining this. To determine this, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 numbers. Okay, if you want to, we could put it in order. 58, 58, 60, 60, 60, 61, 61, 61, 61, 63, 63, 63, and 71. Why am I doing this? Because I need to find my interquartile range, which means 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my median 8 is between these two, so 61. And then my quartiles would be right here, so 60 and 62.5. So my interquartile range is 2.5, because it's 62.5 minus 60. I'm going to take that times 1.5, which is 2.5 times the 1.5 gives me 3.75. Now, what that means is if I have a point that is 3.75 below 60 or 3.75 above 62.5, then that would be an outlier. We don't have one down here, but this up here is definitely, for sure, an outlier. So we're going to say outlier at 71 inches, because they're heights of students. Now, you could have probably determined that that was an outlier just by looking at it, and you could be safe to do that, but I just want to show you how we actually calculate and determine if it is truly an outlier or not. So if you're ever unsure, that's how you do it. Okay? Describe the center and the spread. Now, there are two measures for center that we use. We use mean and median for center, and we use interquartile range, interquartile range or mean absolute deviation to talk about spread. Okay, so is the data distribution symmetric? If it is, it all depends on that. If it is, we use the mean to describe the center, and we use the mean absolute deviation to describe the spread. So if we remember how to calculate that, right? And if it is not symmetric, which honestly most of the time it's not, we're going to use the median to describe the center, and we're going to use interquartile range to describe the spread, okay, which is Q3 minus Q1. So median and interquartile range, or mean and absolute deviation. And let me show you what that looks like, okay? Right down here. The number of nachos sold at a football game concession is shown at the right. All right, so one night, 2 nights they sold 20, 2 nights they sold 23, and so on. And those X, each X represents a total for one night at the football stadium. All right, so we have it is not symmetric. There is no way that's symmetric. So first of all, let's describe. It doesn't say to, but if we were talking about clusters, gaps, I would say not symmetric. There's probably a cluster here, and maybe here. There's 2 gaps. There's a peak, and I don't think there's an outlier. And the reason I say that is because maybe this would have been, but there are 2 of them, so there's not an outlier over there. Okay, so because it is non-symmetric, 2 M's, we are going to find the median and the interquartile range. Okay, what describes the center? Median. Why? Because it's non-symmetric. And I forgot my M again. Dang it. And if it's non-symmetric, what describes the spread? The interquartile range. So let's find that. Okay? Now, believe it or not, if you want to write these numbers down, you can in order, but they're kind of already written down for you. If you can, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There are 21 data items, numbers. So my 11th number will be the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my lower half, and here's my upper half. So the median is 25. 25 nachos sold. Now, the interquartile range, I have 110 on either above or below. So 1, 2, 3, 4, 5. My 5th and 6th number are both 24. So, and over here, 1, 2, 3, 4, 5, both 27. So 27 minus 24 is 3. So I would use the median of 25. So the center is about 25 nachos, and the spread around the center is about 3 nachos. And that just means that from the median, on average, about 3 away. Okay, because this is the median and this is the interquartile range. Okay, let's try another one. slide number 8. We are on to 15 minutes. Sorry about that. Slide number 8 gives us a bar graph. Ooh, it's so pretty. That is definitely 100% symmetric. Okay, so if it is symmetric, which one do we use to describe our center? We use the mean. Why? Because it's symmetric. Now, if you wanted to total them all up and divide by how many, so we have a 2, we have 3, 3, we have 4, 4, 4, we have 5, 5, 5, 5, 5, 6, 6, 6, 7, 7, and 8. You can add them all up and divide by. But guess what the mean is going to be? Yeah, it's going to be 5. So 5, what are we doing here? Hours per week of dance that they practice. So 5 hours. And our spread, because it's symmetric, is our mean absolute deviation. Now, it's probably okay that I did this. So our median, or our mean, is 5. How far away is all of my numbers from 5? So 2 is 3, 3 is 2, 2, 1, 1, 1, 5. 6s, 7s, and 8s. So add those all up and divide by however many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So let's add them up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 divided by 17 means our mean absolute deviation is 1.2 hours. So the data is symmetric. Let me zoom out. This is the sentence you'll have to write, something like this. Symmetric. So it is centered around the mean of 5 hours and the spread around the mean is the mean absolute deviation of about 1.2 hours. You have to write a sentence telling me what you use, so the mean of 5, so it's centered around the mean of 5 hours, and the spread around the mean is the what of about 1.2 hours. So, couple things. We're talking about distribution, clusters, gaps, peaks, outliers, and then we are talking about the center and the spread, depending on if it's symmetric or not. All right, so your assignment is in your textbook. It's actually all of them, 1 through 20. And if you have any questions, you need to come and see me, and we can talk it through. All right, good luck.